Good morning to all. Myself in Satyanarayana, working as an assistant professor in EC department in Nasarawa Engineering College, Economics. Now I am going to explain region of convergence in Laplace transforms and its properties. Region of convergence ROC in Laplace transforms and its properties of ROC, properties of ROC. Suppose the signal f of t, Laplace transform of f of t, Laplace transform of f of t, f of s equals to integral minus infinity to infinity f of t into e power minus st into dt, f of t e power minus st into dt, where s is a complex variable. S is equal to sigma plus j omega. Sigma plus j omega. Okay, here sigma real quantity and j omega here omega complex quantity. Okay, here is S plane, here sigma j omega. S is a complex variable. S equals to sigma plus j omega S plane. Okay, here ROC, region of convergence, where the region at which Laplace transform exists or converges is called region of convergence. Suppose one example, f of t be the signal e power at into u of t, e power at into u of t. Okay, here f of s, transform of f of t, f of s equals to, okay, here integral minus infinity to infinity f of t into e power minus st into dt, because of u of t always present between the intervals 0 to infinity. Magnitude always 1, u of t. Because of u of t, here limits changes to 0 to infinity. Here f of s is equal to integral 0 to infinity f of t equals to e power at into, okay, u of t always 1, here magnitude equals to 1, e power minus st into dt. Okay, combine these two terms here, e power at into e power minus st integral 0 to infinity e power minus of s minus a into t into dt. Okay, here integration limits 0 to infinity e power minus of s minus a into t by minus of s minus a, integral e power ax dx, e power ax by a. Okay, then apply the limits, upper limit infinity and lower limit 0. Apply the limits here. Limit t tends to infinity e power minus of s minus a into t by minus of s minus a minus lower limit t tends to 0. Okay, here limit t tends to 0 e power minus of s minus a into t by minus of s minus a, minus of s minus a. Okay, here transform exists. transform exists or transform converges, transform having some finite value. Suppose here f of s having some finite value. Suppose here limit t tends to infinity. Okay, here e power minus of s minus a into infinity. Okay, here suppose s minus a less than 0. S minus a less than 0. S minus a less than 0 indicates here s minus a negative. Okay, here negative. Okay, negative, positive. Okay, here t tends to infinity. E power infinity equals to infinity. Okay, total value of f of s equals to infinity. Transform not converges, not exist. Okay, f of s having some infinite value. F of s having some finite value. Suppose here s minus a greater than 0. S minus a greater than 0 indicates positive. Okay, here negative, again positive. Okay, minus into plus minus, e power minus infinity, here t tends to infinity, e power minus infinity equals to 0. Okay, first term becomes 0. Here f of s equals to 0 minus limit t tends to 0, e power 0 by minus of s minus a. Here one condition, if s minus a greater than 0, s minus a greater than 0, s greater than a, simply it indicates real part of s greater than a. Real part of s greater than a. Here transform value f of s equals to, okay, minus cancel, plus e power 0 means 1 by s minus a. F of s equals to 1 by s minus a, ROC, region of convergence, s greater than a. Suppose here on s plane j omega sigma s greater than a. Suppose here value a, s greater than a, ROC. S greater than a, okay, ROC. The region at which Laplace transform exists or converges. Okay, here transform value f of s equals to 1 by s minus a, ROC, s greater than a. Okay, here right sided ROC. Here f of t, e power a t into u of t. Okay, right side signal. For right side signal, right sided ROC. For right side signal, right sided ROC. Next we go for another example. One left side signal. Suppose f of t equals to minus e power a t into u of minus t. Left side signal here. Next transform value. Here f of s equals to integral minus infinity to infinity f of t into e power minus st into d. E power minus st into d. Okay, integral minus infinity to infinity minus e power a t into u of minus t into e power minus st into d. E power minus st into d. Okay, here u of minus t, because of u of minus t, time reversion of u of t, here limits or existence of the signal u of minus t. Okay, here u of minus t minus infinity to 0. Minus infinity to 0. Magnitude always 1 and 0 to infinity. There is no signal, simply magnitude equals to 0. Okay, here limits changes to f of s equals to integral minus infinity to 0. Okay, here minus e power a t. Next one, e of minus t. E of minus t value 1. Okay, 1 into e power minus st into dt. E power minus st into dt. Okay, here minus limits minus infinity to 0 e power minus of s minus a into t into dt. Okay, here combine the two terms e power at into e power minus st into dt. Okay, here f of s equals. Next integration. Okay, again integral e power ax dx formula. Here f of s equals to minus, okay, limits minus infinity to 0 e power minus of s minus a into t by minus of s minus a. Okay, here limits minus infinity to 0. Then apply upper limit and lower limits. Here f of s equals to minus, okay, here minus cancel. Limit t tends to 0 e power minus of s minus a into t by s minus a minus limit t tends to minus infinity e power minus of s minus a into t by s minus a. Okay, here f of s, transform of f of t, Laplace transform of f of t exists or converges. F of s having some finite value. Okay, here apply the upper limit t tends to 0 e power 0 by s minus a minus, okay, here limit t tends to minus infinity. Okay, here minus infinity. Suppose s minus a value positive. Simply s minus a greater than 0. S minus a greater than 0. Okay, here s minus a greater than 0 positive. Okay, minus into plus minus into minus plus e power infinity. E power infinity equals to infinity. Okay, transform does not exist or not converges. Next we go for suppose another condition, s minus a negative, s minus a less than 0, s minus a less than 0. Okay, here negative minus into minus plus, again plus into minus e power minus infinity equals to 0. Okay, second term value 0. Here one condition, s minus a greater than 0. The region at which Laplace transform exists or converges for the signal f of t. Here left side signal because of e of minus t, s minus a less than 0. Okay, simply e power 0 1 by s minus a. Here ROC s less than a. F of s equals to 1 by s ROC s less than a. For left side signal, ROC is s less than something, left sided ROC. Suppose here value a, okay, here sigma, next here j omega, s less than a. For left side signal, ROC is left side. For right side signal, ROC is right side. Okay, here first one right side signal, second one left side signal. Next we go for another example for the combination of two right side signals and two left side signals. in previous problem here, first one e power at u of t transform value 1 by s minus a ROC real part of s greater than a. So next another one minus e power at u of minus t, another signal. Okay, again s minus a ROC real part of s less than a. Simply here s greater than a, s less than a. For right side signal, right sided ROC. For left side signal, left sided ROC. Two different signals having same transform but ROCs are different. Here two different signals, same transform, okay, two different ROCs. Again another one, suppose here e power minus at u of t. E power minus at u of t, a signal, okay, transform value 1 by s plus a ROC real part of s less than, real part of s greater than minus a. Simply s greater than minus a. Another signal minus e power minus at u of minus t transform value 1 by s plus a ROC real part of s less than minus a. Simply s less than minus a. Okay, total 4 combinations. Okay, 2 for right side and 2 for left side. Okay, first one is the right side signal, right side ROC. Second one is the left sided signal, left side ROC. Next, third one is the again e power minus a v of the right side signal, ROC is right sided. Next one minus e power minus at u of minus t transform value 1 by s plus a. Okay, ROC real part of s less than minus a. Okay, here we go for properties. For right side signal, right sided ROC. For left side signal, left sided ROC. Next we go for combination of 2 or more signals. Simply linear combination of 2 or more signals. One example, f of t. F of t equals to e power minus 2t into u of t plus or minus e power 2t into u of minus t. Combination of one left side signal and another right side signal and left side signal. Linear combination of 2 signals. Okay, transform of e power minus 2t into u of t transform value. Okay, here 1 by s plus 2 ROC s greater than minus 2. Okay, right side signal, right sided ROC. Next another left side signal, another signal here minus e power 2t u of minus t transform value 1 by s minus 2. 1 by s minus 2 ROC s less than 2. S less than 2. Here f of t is a combination of one right side signal and another left side signal. For transform e power minus 2t v of t 1 by s plus 2 ROC s greater than minus 2. Here right side signal, right side ROC, left side signal, left sided ROC. Okay, here common ROC R1 intersection R2. R1 intersection R2. Okay, here common ROC S plane sigma, here j omega, ROC first one s greater than minus 2. Okay, here minus 2, s greater than minus 2. Next ROC s less than 2. Okay, here s less than 2. For left side signal, left sided ROC s less than 2. Here common ROC in between minus 2 to plus 2. Minus 2 to plus 2. Okay, common ROC minus 2 less than s less than 2. Minus 2 less than s less than 2. Okay, here f of t is a linear combination of right side signal and left side signal. Simply f of t two-sided signal. For two-sided signal, ROC is a strip parallel to the j omega axis. Okay, in between minus 2 to 2. For two-sided signal, ROC is a strip parallel to j omega axis. Next, we go for another example. Combination of two right side signals. Combination of two right side signals. Okay, here f of t equals to e power 2t into e of t plus e power 3t into e of t. E power 3t into e of t. Combination of two right side signals. Combination of two right side signals here, write e power 2t into u of t, transform value 1 by s minus 2. ROC s greater than 2. S greater than 2. Another one, e power 3t into u of t 1 by s minus 3. ROC s greater than 3. Combination of two right side signals. One is the e power 2t into u of t, another one is e power 3t into u of t. Okay, transform value 1 by s minus 2 and 1 by s minus 3. S greater than 2 and s greater than 3. Okay, common ROC here. Okay, here sigma j omega. One ROC s greater than 2. One ROC s greater than 2. And another ROC s greater than 3. S greater than 3. Okay, here common ROC s greater than 3. Common ROC s greater than 3. Okay, here f of s value, here f of s is equal to 1 by s minus 2 plus 1 by s minus 3. S minus 3 here, s minus 3 plus s minus 2 by s minus 2 into s minus 3. Okay, f of s, transform value. Okay, finally here 2s minus 5 by s minus 2 into s minus 3. Okay, here s is equal to 2, s is equal to 3 with the poles of the function f of s. F of s. S is equal to 1 pole and s is equal to 3 another pole. S is equal to 1 pole and s is equal to 3 1 pole. For a combination of two right side signals, ROC is outside of the outermost pole. Okay, right side of the rightmost pole. Combination of two right side signals, ROC is always right side of the rightmost pole. Okay, for first one, for right side signal, right sided ROC. For left side signal, left sided ROC. And the linear combination of two-sided signal, ROC is a strip parallel to j omega axis. And combination of two right side signals, ROC is right side of the rightmost pole. Here s is equal to 1 pole and s is equal to 3 another pole. Right side of the rightmost pole. Next another example. Okay, another one. Combination of two left side signals. Combination of two left side signals. F of t equals to minus e power minus 2t into e of minus t minus e power minus 3t into u of minus t. U of minus t. Here f of s simply minus e power minus 2t u of minus t. Transform value 1 by s plus 2 s less than minus 2. Okay, ROC. Another signal here minus e power 3t into u of minus t 1 by s plus 3 s less than minus 3. Okay, f of t is a combination of two left side signals. Okay, first one is the minus e power minus 2t u of minus t left side signal. Here left sided ROC. Another signal left side signal. Okay, left sided ROC. Okay, here common ROC. S equals to minus 2. S is equal to minus 3. S less than minus 2. Okay, j omega. Here sigma s plane. S less than minus 2 and s less than minus 3. S less than minus 3. Common ROC s less than minus 3. Here s less than minus 3. For a combination of two left side signals, ROC is always left side of the leftmost pole. Left side of the leftmost pole. Okay, here f of s value, f of s is equal to, suppose here two poles, s plus 2 into s plus 3. Okay, here 2s plus 5. 2s plus 5. Here s is equal to minus 2 one pole, s is equal to minus 3 another pole. Okay, two poles here minus 2 and minus 3. ROC is always left side of the leftmost pole. Left side of the leftmost pole. Okay, here combination of two right side signals. ROC is always right side of the rightmost pole. For right side signal, ROC is right sided ROC. For left side signal, left sided ROC. Suppose here s greater than a, ROC, okay, right sided s greater than a. Suppose one left side signal, suppose ROC s less than a, okay, ROC s less than a, sigma, here j omega, here also sigma j. Right side signal, right sided ROC, left side signal, left sided ROC. Suppose combination of two right side signals. One example, suppose ROC here s greater than 2 and s greater than 4. Okay, here for s greater than 2, one ROC, and s greater than 4, another ROC. Okay, 2. Next one 4. ROC is always right side of the rightmost pole. Here combination of two right side signals. Okay, next suppose combination of right side signal and left side signal. Combination of right side signal and left side signal. j omega axis, combination of right side and left side segments. Next one, the combination of two left side signals. Two left side signals. Suppose ROC is here s less than 2 and s less than 1. S less than 1. Okay, here one is the s less than 2, one ROC. Another one is s less than 1, another ROC. Okay, common ROC s less than 1. S less than 1. Okay, here sigma j omega. Combination of two left side signals, ROC is always left side of the leftmost pole.